Hi everyone. In the last video, we created a brand new project and we entered a one rung and a simple start stop circuit, which you can see on the screen. And we had said that stop push buttons are normally closed, and that's how they are in the field. Start push buttons are normally open, and then we added a coil with a seal in contact for the start push button. So if you took a break after that last video and need to load this program, or if you haven't done this yet, go back to the last video. I apologize, the last video is somewhat long, but you could create this rung. Otherwise, open up your CCW software and open the file that you were working on, and then we'll get started with the simulator. So you can pause the video until you do that. So getting started with the simulator, we want to actually run this program. Right now, we used local tags or local variables for the instructions on this rung. So we won't have actual field input outputs or field I/O to deal with. So what we're going to do is we're going to open the Micro 850 tab. If you don't have that tab open, all you have to do is double click on Micro 850 so that you get this particular window open. Now there is nothing to do on this particular page. The important thing before you start the simulator is that we have a communication path established. So right now I have a communications path established. Let me delete that path, which I just did. Okay, and let's create a path. The first thing we have to do then is we're going to start the simulator. Okay, so to start the simulator, on the toolbar, there is a button that says Start Micro 800 Simulator. So we'll click that button. And the simulator window opens. And you'll see the IP address. Now, let's drop this drop down. Now, I have two IP addresses shown here. The simulator is going to use your network interface card that's in your computer as its IP address, because this particular PLC is going to use Ethernet. So you'll have to select a IP address. You'll see that there's a loop back interface, but we don't want that one. And then pick one of your, for the only internet card that you have. Mine happens to be 192.168.1.106. Yours will most likely be some other address, but whatever your internet card is, or I'm sorry, your network card is, that's what you want to select. So we'll select that, and then we have to turn the simulator on. So I'll click the on button. The power button is right here. We'll turn that on. You're going to get a warning that the simulator will only run for 10 minutes, and that after 10 minutes, it's going to get switched back to program mode automatically. You can choose not to show this message. I leave it active only because I'm creating these videos. All right. It's 10 minutes in the standard edition, which is the free edition. If you purchase the developer edition from Rockwell, you will have 24 hours before it goes into program mode. So I'm just going to say OK to that window. Now, before I can download the project that we created to this simulator, I need to set a communication path. So over in the corner of your screen, you'll see connection path, and I'm going to come over on this little tiny button that says set up connection path, and I'm going to click that button. Now you'll get a dialog that says set up connection path, and you'll see some items in there. You might only have one item. I happen to have 4 different items because I've been doing some other things. But you want to select the IP address that you chose for your simulator. So I chose the Winner Linux, and I call that's my computer name because I run Windows and Linux on this machine. And in order to select it, you see here it says double click to select the path. So I'm going to double click. It moves the selected path in, and then I'm just going to say close, and you'll see that my path, my communication path, has been established. Now that the simulator is turned on and it's powered up and we have a communication path, we can now download that ladder logic to the simulator. Now, on the toolbar, you will see that there is a build button. And what the build does is it checks for errors. It will create the object code. It gets things ready. There's also then a download. Download says I'm going to take the program code from the computer and download it to the PLC. There's also an upload button. Upload says that if I have a program in the PLC, I can upload it from the PLC to the computer. So we're going to do a download. Now, if you don't do the build first, the download will automatically do a build. I like doing the build first so that I can correct any errors I might have before I download it. So I'm going to do a build just by clicking on build, and it's going to start chugging away. Depending on how long your program is, and the length, the number of rungs, how much code you have, it may take a while. Now, another window opened, and you'll notice that I have an error here that says internal error. Every once in a while, I get that error, and I think it's my particular computer. So what I'm just going to close this window, and I'm going to do another build on it. So if you get that error, do what I'm doing. Otherwise, hopefully this next time I'll be okay. And here we are. So this is something with my system here, and I just haven't had time to troubleshoot as to what's causing that. But anyway, I've got build, 1 succeed, no failures, everything's up to date, nothing was skipped. So now that I get a good build, I can now click the download button. So I'll click the download button, and again, things will chug away. If you do not have this communication path set up, you'll get errors, and you may even have to restart the software to get things back in sync. So again, I get a message down here, succeeded, 1 up to date, and it's still working. Now it's going to tell me that the project in the controller will be overwritten with the current project. So whatever I'm downloading, it's going to overwrite what's already in the processor memory. Also, the controller has to be switched to program mode. There are 2 major modes on a PLC. One of them is run mode, which actually runs the program, and then the other one is program mode. And program mode is the mode where I can upload programs, I can download programs. Later on, you'll see you can do online edits. So while the program's running, you can actually do some editing. And it says controller will be switched to program mode to perform the operation. So when I perform the download, it's going to automatically, if the processor's in run mode, it'll switch it to program mode. And then you'll probably get a message saying, do you want to go back to run mode again? So I'm going to do a download. You'll see that there's another option here for download with project values. We'll talk about that another time, because you could preload variables with data and download that data along with your project. But I'm just going to do a download. So we'll click download. And again, it's going to be chugging along. It's getting everything set up for us. When it finally gets downloaded and switches to run mode. Here it is. Download is complete. Change the controller to run mode and execute. I'm going to say yes. Again, you'll get the message about 10 minutes. I'm going to say okay. And your window should switch over to your ladder logic, which it just did. And take note, the red and the blue. Red means that I have power flow through this particular device. It's closed. I should have power flow. Think about the power rails as being your power source. So I've got plus 24 volts or 120 volts, or if you're overseas, 220 volts. All right. But most of the time it's 24 volts DC, and the other side is the common for that, or the ground for that. To make this operate, so this means I have power flow. To make this operate, I can come to the start push button. Now I don't have anything to press, but if I right click on that start push button, I can come over here and say toggle the Boolean value. So I can toggle it from a 0 to a 1 or a 1 to a 0. I can also use the shortcut key, which is the Control plus T. So I'll toggle the bit, and now you'll see that everything turns red because I now have power flow through this rung, the coil energized, its contacts change state. Again, if you don't understand how relays work, there's a video in my channel that'll tell you how relays work, and there's a lot of others on YouTube. You need to understand relays. So that coil energized, its normally open contact change states, so it's closed. Start push buttons are momentary for the most part, so I'm going to toggle this off, and you will see that I still have power flow because the seal in is there. To stop it, I'll just open or make like I'm going to press the stop push button. Everything turns blue, which says I have no power flow in that rung. And then I'll put this back the way it's normal state. So our first program runs correctly. But start stop push buttons are either on an HMI screen, which is a human machine interface, or they're actual physical push buttons out in the field. So let's make some modifications to this program. On the toolbar, we need to disconnect from the simulator. So I'm going to press this button, click to disconnect. And then I'm going to, on my taskbar, the simulator's down here. As you can see there's some indicators. The power's on. I'm in run mode. I'm going to just close the simulator window. That turns off the simulator. I now want to add some physical field devices. I can simulate physical field devices. So physical field devices are available to the entire PLC project. These local variables are only going to be available, their status, their values, are only going to be available to the main routine, the routine that they reside in. So to create physical I/O, I'm going to come into the project organizer and I'm going to go to global variables. Global variables are available to the entire project. And the input-output devices, the actual physical field devices, will be in the global variables. So I'm going to double-click on global variables, and I will get up a global variable selector screen. It looks just like the Excel spreadsheet that we used when we created the tags. You'll see that in the Micro 800 series, there are a lot of tags that are already created. Well, this is the digital output 0, digital output 1, digital output 2, and so on. And if you scroll down, these are all the digital inputs. And then you'll see some system tags or some system variables that we'll talk about in a later video. So what I'm going to need is I'm going to need 2 inputs. I need 1 input for the start push button, and I need 1 input for the stop push button. I'm going to just choose 2 inputs. So I've got an IOEMDI. I'm going to put the start push button on input number 9. And what I'm going to do is I'm going to assign an alias tag. So I'm going to click in there and assign an alias. You know, an alias is just another name for a variable. I'll give you an example. My real name is John, but I go by Skip, which is a nickname. Well, Skip is my alias. So it's just another name for the same thing. I want that to be my start push button. So I'm going to give it an alias of start PB. That way, if I can't remember what the IO point is, I do know that it's a start push button, and I can use the alias to reference the start push button. So I'm going to press enter, and then I'm going to assign the stop push button to input 10. Now, at our current level, I'm going to use a physical output for the relay coil. In PLCs, there are tons of internal relays. I would not have to change the program code for the output circuit. I could use an internal relay coil, an internal relay contact, but I'm going to change it to an actual field device. So we need to choose an output. So let's pick an output. So we have to come up to the IOEMDO, and I'll pick output 0. And I'm going to give it an alias. And you don't have to give it an alias, but I like to do that because it gives it a function for me. And I'm going to say run control. And press enter. So I used the same variable names. Now I can do that because the variable run control that I used before is local to the routine that the rung is in. The one I'm creating now is available to the entire project. Now, I normally don't like to give variables the same names. So what I'm going to do is I'm going to go back over into the local variables, and I'm going to delete those names. So I'm going to open up my local variables in the project orienter, or in the project organizer. I keep saying orienter. And I'm going to delete these tags. And all I have to do is come over on this blue. I'll click, and I can drag down to select all those tags. And I'm just going to press the delete key on my keyboard. And I've deleted those tags. Now I'm going to go back to the ladder logic. The ladder logic is still open. It should be in my main POU. And you'll see, look at, I've got these yellow explanation points there because, hey, that's really not a tag. It's telling me I've got a problem there. There's something wrong. And there is. So I'm going to assign the tags that I just assigned. I'm going to double click on the normally closed button. And this time I'm going to assign the tag from the IO tab. On the IO tab, I'll click it, and then there's that same screen we just were on, and I'm going to scroll down the list until I find stop push button. So I'll click on stop push button and say OK. Now I have that assigned to input number 10 and a friendly tag or an alias called stop push button. Now, remember I told you in the field, stop push buttons are normally closed switches. They're normally closed devices. So I also need to change the the type of instruction that's there. I'm going to change this instruction, and I'm going to make it a normally open contact, or an examine if closed, or direct contact. So I'm going to right click on that instruction, and I'm going to choose properties. And I get a properties dialog box open on the side. You'll see where it says modifier. I'm going to change this from a reverse contact just by clicking the drop down. And I'm going to say I want a direct contact. And I'll make it a direct contact, and you'll see that it now changed to a normally open contact, or what's called an examine if closed, or what's called a direct contact. And again, I'm going to do a video to explain those instructions. I already did, but I'm going to do another one to supplement it. And I'll just click away so that the properties dialog. So I'm going to do the same thing for these other instructions. So the start push button is going to be IO, and I want start. You could also just double click on this to enter it instead of clicking and saying okay. I'm going to make this run control, IO, and scroll up to run control, and then I have to apply run control. Run control. There it is. Okay, I picked it. If you took notice, I clicked here. I don't know if I can get that the way I did that, but anyway, you could pick out of a list also. So now I have actual field devices assigned to this project. So I'm going to save this. Again, it's always good to save periodically, especially when your programs start getting longer. You do all that work and then something happens and you lose all that work. So I'm going to now build the program, and we'll make sure we don't have any errors. I get that internal error again. I apologize for this, but I'm actually glad it's happening so that you also see that sometimes you can get around it by just doing another build. And it did the build successfully. And then I'm going to turn on the simulator. When I first started using this, because I've only ever used hardware, one of the things I always forgot to do was to turn on the simulator. So it was like trying to download to a device that had no power on it. So make sure you turn on the simulator or start the simulator and then turn on the power. You should not have to, and respond to the dialogue, you should not have to reset your IP address. And then I'm going to come up, and now I'm going to download it. Don't worry if you make a lot of mistakes. I still make a lot of mistakes, even though I've done some pretty hefty projects in this software already. We're now going to download. Okay, and we're going to say yes and okay. We'll wait for the simulator to start up. Okay, notice everything's blue at this point, and it should be. This is normally open. This is normally open. I'm going to come on my taskbar and open up the simulator window. Now, again, stop push buttons are normally closed in the field. I can come in here and say, these are my inputs. These are all the inputs. So you can see I have 28 inputs. And you're going to say, well, no, this is 27, but it's 0 through 27, which is a total of 28. And here are the outputs. There are 20 outputs, 0 through 19. Please remember that in the PLC world, 0 is a number. And I'm going to be doing a video of my own on number systems. This is another reason why number systems and understanding them is important. So I'm going to just, to turn on an input or to make it like you're pushing the button, I'm just going to click on number 10, which is the stop push button. I'm going to click on it. Notice it turns on. There's also some status indicators on this side. The PLC hardware itself, if you had a real piece of hardware, has status indicators, which are just LEDs or tiny little LEDs that tell you which inputs are on and which inputs are off. So that right now the stop push button is closed. The contacts are closed. If I come back to my ladder, let me just move this down. You'll see that I now have power flow through here because the contacts are closed. To make it run, I'm just going to click on the start push button, and then I'll release it again. So it's just like me pressing the start push button. I would press it, it will turn on, the status indicator turns on, and then I would release it, it would turn off. And you see the same function occurred. If I look at my, come here, if I look at my output, I have output 0 on, output 0 is on. To make it turn off, I just have to press the stop push button. Boom, boom. And it's back to normal. So I simulated 2 push buttons, which are momentary. That's why I click. So I click, click. Everything starts up. I click, 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 click. Everything stops. So it's just like using field devices. This is a great tool to learn how to program PLCs. Okay, that's all I'm going to do. I said I would try not to make this video as long as the last one. That's all I'm going to do for this one. Come on back for the next one. I'm going to talk about how PLCs actually execute their program. I'm going to and we're going to add more rungs to this program so that you can see how things actually work inside a PLC. So I'll see you in the next video.